this notion of a set to define what we call a function. But before defining a function, there are some few things that I mentioned, but I decided to not to explain them mathematically. I said, you see, if I take, let's say a set that is given by let's say the A is the same set, which is 1, 2, and 3. Then I take another set, let me call it C for Caroline, that is contained, let's say 4 and 5. Or in fact, let me take an element of the set all of those ones in the set A, and 4 and 5. So let's say 1, 2, and 3, 4, and 5. Okay, who can tell me what is the relation between the set A and the set B? Who can tell me what is the relation between the set A and the set B? Who can tell me
A
what's
is a
the relation?
subset of,
Huh?
yes, I was saying A is a subset of C.
A is a subset of C. And then what else that you have in A that you don't see in C? Yeah, I mean, you said that you have in C that you don't see in A.
Yes, so two elements like 4 and 5 are not in A.
Okay, 4 and 5 are not in A.
Yes.
Okay. Then when 4 and 5 are not in A, then the question is that how do we represent? How do you call this mathematically? So you see, 4 and 5, they are not in A. So basically, if I take the set that is containing only 4 and 5, I can define a new set, right? I can define a new set maybe by K for Kotsia, by 4 and 5. So the relation between now A, C, and K is the following. So you see that if I look at the set K is actually basically the complement of the set A. The complement of the set in the set, what is the other set name? In the set C. You see, we're taking the complement. So sorry, there are CC here. Maybe let me call this one by L for Letitia, to avoid having the C complement and the C. That small c there's looking like in power, so it stands for the complement. So this is generally written like this. So the set K can literally be written as the set L removing the set A. So, or some people write it like this in a mathematic L minus A. L minus A. So that's the notion of complement. And then I think that would be now the relation that I was thinking to say earlier on. I mentioned something of inclusion. Then I will also explain something about intersection just now before I come to this one. So there is something else that I need to mention to you. Now, if you take the set A and you take the complement of the set A, then you find exactly that set. No, I think it's L that I'm referring. Oh, it's L that I'm referring to. So I think I made a mistake here. So here is L. So please, you're supposed to tell me that, say you forgot, that is L in A, right? Because A is the bigger one. Which one is the bigger one? Oh, L is the bigger one. Sorry, then A is the smaller one, yeah. No, then it's correct. L is the bigger one. So I'm going to keep the A here as it is. That is correct. Now, you see, when you take A and A complement, you put the U. U here stand for the union or an or. So it's like I'm going to also actually just add to it now. That gives you the set L. So what is the U stand for? So you see, A is given by, I can't remember, 1, 2. Is it only 3? 1, 2, and 3. And the A complement is given by, I think, 4 and 5. So it means that the new set that you're looking for is the element that is in the set A, or they're in the set B. So this one gives you the new set, which is 1, 2, 3, 4, 5, everything in the first one or in the second one, which is the set L. So basically a set and its complement give you the original set. So then the O is done. So now the question is that if I take a different set, let's say I'm going to take a set, give me any other name, I can't remember whose name. Have I read the 7-minute? If I take any name, let's say I take D, I take a set, let's say 1, 2, and then let's say 6. Then I take a set E. I'm going to take 1, 3, and 4. Now the question is that how is that O going to be going to work? So then the set D or E or D is the same thing. D or E can also be E or D is the same one. So if I rewrite them, that is 1, 1, 2, and 6. 1, 2, 6. Then the O, 1, 3, and 4. So how do I take it? Because this time around, there are some elements that are in both sets. And I said a set is a well-defined collection of a distinct element. So those ones that you have in your new set that you are going to get should be the one that of distinct. They should not be 1, 1, 3, 3, 4, 4. So which means that the repetition will be removed. So you're just going to get 1, 2. Let's say you order it 3, 4, and 6. It doesn't matter if you put 6 in a different order. You see, 1 is only written once in this D or E. So this U is called the union. So generally U here stands for the union. So you take the element that in that, and sometimes you represent it by something like this, an O. It's like a V. Now, if it's the union, the question is that people start thinking of union in the terms of marriages, please. For those who are already married, yeah, our union was in 2007. Ours is just recent. For those who are okay, if there's a union in terms of set, then what is the intersection when you look for things that are in both? So you see here, what we did.
Sir, you've
There are
reached
some.
the 7-minute mark.
I've reached the 7-minute. Thank you so much. Let's stop the recordings. Because we didn't stop, so we're going to stop at 11:30. We'll stop completely. I'll do one last discussion and then we